or methods that can be used by economists to analyze economic problems or to construct theories and develop policy recommendations. What I'm trying to say is that let's try to define it formally. If you want to define methodology of economists, the methodology of economists, the methodology that is MOE, methodology of economists refers to the principles, and approaches used by economists to analyze economic problem. To analyze economic problems. To analyze economic problem, construct theories, and develop policy recommendation. Recommendations. That is what methodology of economy means. It means principles and approaches used by economists to analyze economic problems, construct theories, and develop policy recommendation. This is exactly what methodology of economics entails. That is why, if you look at what I said when I started this class, I said methodology of economy means what are those methods, what are those principles, what are the approaches, what are those approaches that are available within the discipline that economists can use to analyze economic problem, to construct theory, and develop policy recommendation. This includes distinguishing between different types of economic analysis, meaning that the approaches or the methods which you intend to use will be determined by the what? By the type of economic analysis you are trying to do. So that is what methodology of economy simply want to tell us. The method that you decide to use at the end of the day will be determined by the types of economic analysis, the role of assumptions, and the tool used in economic research. This is what will determine the methods or the principles or the approaches you are to use if you want to analyze economic problems. Now, there are three basic methodological approaches that economists can use to analyze economic problems. There are three basic approaches or methods that economists can use to analyze economic problems. What are these approaches or methods that economists can deploy to analyze economic problems? Number one is what is referred to as graphical methods. Graphical methods. Number two is mathematical methods. Mathematical methods. Mathematical methods. And the last one is the empirical methods. The empirical methods. Let's take each of these. Let's take them. Let me discuss each and every approaches that can be deployed to analyze economic problems. The first one is graphical methods. These graphical methods provide visual representation of economic relationship, thus making it easier to understand trends, correlations, and theoretical models. We are going to see that shortly, where, in fact, in economists rely majorly on the graphical and mathematical methods to analyze economic problems. I'm going to show to us shortly what exactly, graphical methods, the way it can be used to analyze economic problems. Now, let me start my discussion of graphical methods. If you look at what I said about graphical method the other time, I said graphical methods provide virtual representation. Virtual representation. It provides, that is the first one, graphical methods. Graphical methods provide virtual representation of economic relationship. Representations. Virtual representations of economic relationships. Making it easier. Making it easier to understand. Making it easier to understand. Making it easier to understand. Trends. Correlations. And theoretical model. So the commonly used graphical method includes the commonly used one of these approaches, of this particular approach, includes one, demand and supply. Demand and supply. If you have demand and supply, is like this: price, quantity, demand and supply. If you take a look at this diagram, you can see that it provides what? Virtual representation. That is what graphical methods do. It provides what? Virtual representation, something that you can see of what? Of economic relationship. What's the economic relationship is trying to show to us here? It's trying to show to us the relationship between the price and the quantity demanded of a product. So you can see that it provides what? It provides virtual representation. It provides virtual representation. Something that you can see clearly. Virtual representation of what? Of economic relationship. Of economic relationship. What's the economic relationship in this case? The economic relationship is trying to show to us is between price and the quantity demanded. That is what the relationship is trying to show to us. So you can see that graphical method provides virtual representation of economic relationships, making it easier to understand trends. At times, you can also use bar charts like this. You can use bar charts. This also provides what? This also provides virtual representation of economic relationship. So this is how graphical method is being employed to analyze economic problem. Another example or commonly used graphical tools is production possibility frontier. If you look at your production possibility frontier, this also presents virtual representation. It also provides virtual representation. If you have your production possibility frontier drawn like this, X1, X2, look at it. This also provides what? It provides virtual representation. We call it PPF, production possibility frontier. So it illustrates how it shows trade-offs between two goods in an economy, between X1, commodity X1 and commodity X2. The trade-off between this product, that is what PPF shows. You can see that this also provides what? Virtual representation. Another commonly used graphical tools is what we call indifference curves and budget constraint. Indifference curve and budget constraint. You know, your indifference curve can be drawn like this. You can draw your indifference curve like this. X1, X2. Your indifference curve is like this. Your budget line is like this. This is your budget line. You can see that this also shows what to us what? It also shows to us. That is why we've said is graphical method provides virtual representation of what? Of economic relationship. This indifference curve are budget constraint. This is the budget constraint. This is the budget constraint. This is an indifference curve. So if you look at the two, they are used in what? In consumer theory to analyze preferences and choice. That is what they are being used for. These two, the two, that is budget line and IC curve, both tools are used what? Both tools are used in what? They are used in consumer theory to analyze preferences and choices. That is what they are being used for. We have many of these things that, many of the examples that can be cited in this regard. Also, by the time you get to your trader level, when you be exposed to the concept of ISLM curve, this is also provides a virtual representation of Phillips curves or Lorentz curve. All these things also provides virtual representation. That is one of the methods that we economists use to analyze economic problems. Another type of approach that we normally deploy in our discipline in economics is mathematical methods. It's mathematical methods. That is more reason why I will advise all of you, if you are not, if you don't know math, you may have challenges in the course of this program. So try to equip yourself on quantitative techniques. Because you need to know how to use most of these techniques to analyze economic problems. So mathematical method is crucial in economics for developing precise models, deriving logical conclusions. Some key mathematical tools that we use in economics are what? Optimization techniques. Optimization techniques. Optimization techniques. Or let me just put it simply. For instance, if you looked at in economics, we can represent our demand curve as follows. The demand curve can be represented as this. The demand curve can be represented as A minus BP. You can see that this is what is referred to as demand function. If you look at the way I write out this demand function, I use some mathematical notation to specify a typical demand function. This QD means quantity demanded is a what? Is a function of price. And the relationship between them is negative. You can see. That is, whenever there is an increase in the price of a product, quantity demanded falls. So this is a mathematical representation. This one provides precise model. So mathematical method is crucial in economics for developing precise model, and it helps us to derive logical conclusion. So one of the mathematical tools include optimization problem that I said the other time. And what I mean by that is, of course, maybe at your level, we may not expose you to optimization techniques now, but when it gets to theoretical level, definitely we will expose you to optimization problem. So under that, we'll be making use of calculus for marginal analysis in macroeconomics. We'll be making use of calculus, Lagrangian multiplier for constraint optimization. These are things that we use in mathematical method. Another tools of mathematical method tools is differential and difference equation. Is differential and difference equation. These are tools. These are mathematical tools. These are mathematical tools. Mathematical tools. Mathematical tools. Mathematical tools. The first one is optimization techniques. Optimization techniques. Optimization techniques. The second one is differential and difference equation. Differential and difference equation. And difference equation. And difference equation. All these are mathematical models. Another one is linear algebra and matrices. Linear algebra and matrices. Linear algebra and matrices. These are another mathematical tools. Linear algebra and matrices. That is number 3. 3. Linear algebra and matrices. Another one is what is referred to as games theory. Games theory. All these are mathematical tools that we can use to analyze economic problems. Another one is control theory and dynamic programming. Control theory. Control theory and dynamic programming. Dynamic programming. All these are mathematical tools that we can use to analyze economic problems. Another very important, very important tools in mathematical approach is econometric model. Is econometric model. Is econometric model. Of course, when it gets to 300 level, we will definitely expose you to econometrics. So this is another tools that we can use or that we normally use in what? In mathematical model. So under this econometric model, we have structural models that is based on simultaneous equation to capture economic interaction. So that is under econometric tool. We have structural model based on simultaneous equation to capture economic interaction. The last approach that I want to talk about now is what we call empirical methods. 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 Under these empirical methods, what does empirical methods? This technique, this is a technique that helps, that empirical techniques help validate economics theory using real world data. That is what it does. So whenever we use empirical method, we use it to validate economics theory using real world data. So some widely used empirical tools are descriptive statistics. Some widely used empirical tools are descriptive statistics. Descriptive statistics. Descriptive statistics. And under that, we have what we call mean, median, variance, standard deviation, standard deviation, we have skewness, and we have kurtosis. All these are captured under descriptive statistics. They are all captured under descriptive statistics. So also, part of empirical methods that you can use to analyze economic problems are economic techniques. Techniques. This is also employed under empirical methods. Whenever you are conducting, writing, doing a research, so when you need to specify economic model, you now want to analyze those economic model. So the method that are available that you can use, that is, we call it economic techniques. We can use what we call ordinary least square. Ordinary least square. That is econometric techniques. Econometrics techniques. You can use what we call ordinary least square. Ordinary least square. That we call it OLS. Call it OLS. So we use it to estimate relationship between variable. We use that to estimate relationship between variable. Another one is what we call generalized method of moment. Generalized method. Generalized methods of moment. We call it GMM. Generalized method of moment. This is used in panel data analysis. We use it in panel data analysis. Another tools under economic techniques is time series analysis. Time series analysis. What does time series analysis mean? When you collect data from 1970, for instance, up to 2025, you are not trying to analyze that data. The data that you've collected, we call it time series. So under that time series, you can use ARIMA model, you can use VAR model, you can use contribution model. That is time series. Time series analysis. All this can be be used in what? Can be used in empirical methods. We also have difference in panel data model, and so on and so forth. All this comes under empirical method. Some also, there's what we call computational method as well. This computational method also come under empirical methods. Example of that is Monte Carlo simulation, Monte Carlo simulation, Monte Carlo simulations, machine learning applications, machine learning applications in economies, Bayesian econometrics, and so on and so forth. So now, having told us about the three basic approaches in economics that economists can use to analyze economic problems, what are the strengths and weaknesses of each of these methods? That is what we want to talk about now. What are the strengths and weaknesses of each of these methods? Let's start with the first one, graphical methods. What are the strengths of graphical method and what are the weaknesses of it? The number one strength of graphical method, strength of graphical method, let me call it GM. The first one is that it's very easy to understand and interpret. Easy to understand. It's very easy to understand and interpret. That's number one advantage or strength of it. The number two is it helps to visualize trends, relationships, and distributions. Relationship, and distributions. It helps to visualize it. You can see it when merely looking at the diagram. You can see trend. You can see how those variables are related, as well as distribution. So these are the strengths. Another one is that it is useful for identifying outliers and anomalies. It is useful to identify outliers and anomalies. What do you mean by outliers? Something, for instance, if you have a diagram like this, let's assume you have a diagram like this. Suddenly, you just have something like this. This is an outlier. Or anomalies. So you can see that when looking at this diagram, you can identify outliers. That is what it does. That is one of the strengths of graphical methods. It helps us to identify outliers and anomalies. Another thing that it does is that it supports exploratory data analysis before applying statistical methods. It supports exploratory. It supports, that's number 4, strength. Number 4 strength is that it supports exploratory data analysis before applying statistical method or model. Models. The 4 are strengths that are being associated with what? With graphical methods. Let me repeat the number 1. The number 1 is that it's very easy to understand and interpret. The number 2 is that it helps to visualize trend, relationship, and distribution. Number three is that it is useful for identifying outliers and anomalies. The number four is that it helps to support exploratory data analysis before applying statistical model. What are the weaknesses of these methods? What are the weaknesses of this method? That is of graphical method. Is that one, it cannot establish causality between variables. It cannot establish causality. What do you mean by causality? It can't tell us cause and effect, that this particular variable is one that is causing this other variable to happen. It can't tell us anything about causality. That is number one weakness of this method. It cannot establish. It can't tell us cause and effect. It can't establish. Sorry, established. Cannot establish. It can't establish causality between variables. Which one causes what? It can't tell us anything about it. That's what means causality. It can't tell us that X causes B, causes Y, or Y causes X. It can't tell us anything about it. So it cannot establish causality between variables. Another weakness of this particular method is that it is limited in handling complex relationships. Where we have complex situation, it can't handle it. It cannot handle complex situation. That means that it is limited. It is what? Number two, it is limited in handling what? In handling complex relationships. Complex relationships. It is limited in handling complex relationships. Number three, which is another weakness of it, is that it is sensitive. It is sensitive to data scaling and representation choices. If you draw a graph now, let me tell you something about data scaling. Assuming you draw a graph. Assuming you draw a graph on graph sheet. You draw a graph like this on the graph sheet. If you try to adjust the scale, it can give you another result entirely. So it's highly sensitive to data, especially if there are some variable that, let's assume we have the variable X and Y. For instance, this one is measured in Naira. For instance, this variable is measured in Naira. This one is measured in inches. And you plot these two together. You can see the problem. Once you try to adjust, maybe you want to now change these inches, you want to turn it to Naira, so that two of them will be on the same what? They have the same unit of measurement. This diagram can what? It can give you something different. So that is, it's very sensitive to data scaling or representation of choices. That is exactly what, one of the weaknesses of that graphical method. Now, let's now talk about mathematical method. What are the strengths of mathematical methods? What are the strengths and the weaknesses of what? Of mathematical methods. Mathematical method, number one strength is that it provides a formalized strength of mathematical method, strength is that it provides a what? A formalized theoretical understanding of relationships. That's number one strength. It formalizes it. For instance, if you say the higher the price, the lower the quantity demanded, like this is a mathematical representation of demand curve. So you can look at, if you look, whenever you see this type of thing, you see this equation written anywhere, what comes to your mind is that this is what? This is a demand function. But if you have something like this written plus, if this one turns to plus, it is no longer demand function, it now makes it supply, because there is a positive relationship between price and quantity supply. So you can see that it's a mathematical representation that formalizes these laws of demand. That is what the strength, one of the strengths says. Yeah, it provides a formalized and theoretical understanding of relationship. Two, can generalize result. It can be used to generalize result using well-defined equation. Can generalize result using well-defined equation. That's another strength. It can what? Generalize. It can be used to generalize results using what? Using well-defined equation. This is another strength of mathematical method. So you can generalize it. So to say that they are the price, the right quantity demanded, mathematical method can help us to generalize it using a well-defined equation. Another one is that it is useful for predicting economic outcomes. Mathematics can be used to predict economic outcomes. So it is useful for predicting economic outcomes. It is useful for predicting economic outcomes. You can use it to predict. For instance, if you have time series data from 1970 to 2024 or 25, for instance, you can make a projection for up to 2030. You can make a projection. So what helps you to make this projection easily is because you are employing mathematical methods. So it is useful for predicting economic outcomes. Another one is that it helps in policy formulation by defining economic model. It helps in policy formulation by defining economic model. So these are strengths of mathematical model. What about the weaknesses? What can we say about the weaknesses? Number one, weaknesses of mathematical methods. Weaknesses of mathematical method. One, it requires strong assumption. E.g., example, linearity, rationality, and so on and so forth. That's one thing. If you are employing or deploying mathematical method, it requires strong assumption to say assumption of linearity or rationality. Two, it may not capture real-world complexity. It may not capture real-world complexity. Real-world complexity. It may not capture real-world complexity. E.g., behavioral factor. For instance, if you look at human being, our behavior, that is why social science is quite different from physical science. physical science, what are involved in physical sciences, they are not what? They are non-human materials. Non-human materials. What do I mean by that? It does not involve human being. But in social sciences, you are dealing with human being. Because you are dealing with human being, our behavior can be sometimes be described as being erratic. You may expect the fact that Mr. A and B behave this way doesn't mean that Mr. C and D will behave the same way. So that behavioral factor makes it a complex, situation. So mathematical model cannot or may not capture the real world complexity like behavioral factor. That is the meaning of that. It may not capture the complexity. Another limitation of mathematical model is that limited without empirical validation using actual data. It's limited without empirical validation using actual data. That is another weakness. That is limited. Number 3, limited without empirical validation. Using real world, using actual data. The only thing that can make mathematical method to be relevant is when we can use actual data to validate the result of that mathematical model. So if you cannot have actual data to validate it makes it a limited tools. It limits its usefulness. So that's why I said it is limited without empirical validation. It's only when we can empirically validate it, that's what makes it useful. If you cannot empirically validate mathematical model, it's now run it what? It makes its usefulness to be what? To be limited. That is what it means. So these are limitations or weaknesses of mathematical model. The last but not the least is empirical methods. Empirical methods. What are the strengths of empirical method? Number one, uses real world data to validate theories. What do I mean by this? For instance, if you collect data on people, we now study their behavior whenever there's an increase or reduction in price. How does that affect their demand? We can actually collect data on the behavior of people. By the time we collect those data, we then try to analyze the data. So what we're trying to do is that we are using real world data to validate theory. The theory that we say they are the price, is it true that whenever there's an increase in the price, the quantity demanded will fall? We can only know this if we now collect data on people, on consumption. If you collect consumption data and try to analyze this, our analysis would validate or refute that theory that says whenever there's an increase in the quantity demanded will fall. So one of the usefulness of empirical method is that it uses real world data to validate theories. That is number one. Two, it can be used to establish causal relationships. It can be to establish causal relationship. If you look at what I said under graphical method, one of the disadvantages of graphical method is that it cannot establish causal relationship between or among variables. But if you take a look at empirical model, this can establish causal relation. It's an advantage. So why? Because there are some tools that you can use that will help you to obtain or establish causal relationship. For instance, if you use parallel data or experimental variable, This helps you to what? To establish causal relationships. Another strength of empirical method is it incorporates control variable to minimize bias. It incorporates it incorporates control variables to minimize bias. What do I mean by this? Let me explain. What do I mean by that? Control variable. Assuming you have this demand function that quantity demanded of a product is a function of what? Price is a function of population, is a function of income. Let's limit ourselves to 3. If what you are interested in knowing in this relationship, you want to see how does price affect quantity demanded. This is, you are interested in how does price affect quantity demanded. But if you are specifying economic model, you can't use price alone. You cannot use this price alone. You also have to think of other drivers of quantity demanded. Other drivers like population, income, they can also affect the demand. These are what we call control variable. Because if you include this control variable in this model, it helps to minimize biases. That is what I've said. It helps to minimize biases. But if you don't put this control variable, if you only say quantity demanded is a function of price alone, without considering other drivers of demand, your result may be biased. In order to minimize this bias, you need to include some other control variable. That's what it means. So another strength of mathematical method is that advanced techniques can handle complex and non-linear relationships. That is another strength of empirical methods. It can use advanced techniques like machine learning to handle complex and non-linear relationships. Now, let's talk about weaknesses of this method. Number one, dependent on what? Dependent on data availability and quality. That is number one. That's number one weakness of this method. It depends mainly on data availability and quality. 2, results can be sensitive to model specification. Results can be sensitive to model specification. At times, where you need to use linear relationship, you use non-linear relationship. You can say that your results can be what? You end up getting different results. So results can be sensitive to model specification. So how you specify your model will determine your results. That is what is meant by results can be sensitive to model specification. Another issue with empirical model is issue like multicollinearity, endogeneity, and omitted variable bias may arise. I know this may be too advanced for you at this level, but I just want you to know that in economics, we have some sophisticated, some robust techniques or method that we can use to analyze economic problem. But one of the challenges of empirical method is that issue like multicollinearity endogeneity, and omitted variable bias. Variable bias may arise. Multicollinearity means assuming we have, let me just give an example of that. You may need to bother yourself so much about these terms, but you just want to expose you to it so that as you progress in your study, you will see, once you are going to meet them in the course of the program. So if you see them, it won't be new to you. Say, oh, I've seen this thing before, I've heard about this concept before. Multicollinearity simply means, assuming you have x1, let's say y, let's say we have y as a function of x1, x2, x3. We don't expect this relationship between x and y to be what? To be high. You don't expect the relationship between x and s3 also to be high. You don't expect the relationship between s2 and s3 to be high. But if you see the relationship between them being high, that means they must have, the problem of multicollinearity must have, arised from that. So because in the model estimation, if you want to estimate model and want to have accurate results, the relationship between them is expected to be what? The correlation between them should be expected to be low. But if it is high, that means the two of them are, they are almost related to each other. So as a result, it may bias your result. So we don't expect that to happen. That's why we said issues like multicollinearity may arise when you are using empirical method. The last but not the least is computationally sensitive, intensive for large data sets. It's computational intensive for large data sets. So it requires, for large data sets, the computation becomes so, it's not, it doesn't become so easy again, because the larger set means that you need to employ some advanced techniques to handle the estimation. So these are methods that can be used by economists to analyze economic problems. If that is clear, let's try to talk about the role of assumption in economic modeling. The role of assumption in economic modeling. The role of assumption in economic modeling. The role of assumption. The role of assumption. The role of assumptions in economic modeling. The role of assumption. Before we talk about the role of assumption, first of all, we need to talk about economic models. What do you mean by economic model? Model. What do you mean by that? Economic models are simplified representation of reality. Economic model are simplified representation of reality. Economic models are simplified representations of reality. Used to analyze complex economic processes. So that is what it does. Economic models are simplified representation of reality used to analyze complex economic processes. Now, for you to be able to come up with economic model, for you to derive or use economic model or to develop economic model, assumption play a crucial role in constructing this model. And I'm going to show to you shortly what we are trying to say. Assumption play a crucial role in constructing this model because it helps economists to focus on key relationships while ignoring extraneous details. That's what it does. It helps us to keep focus on the key relationship and ignore extraneous details. Let me give you an instance. What we're saying is that if you take a look at, let me use our usual illustration. Let me use our demand. Let me say demand. Okay, look at this curve. Now, look at this curve. Yes, good. Look at this curve. This curve, price Q. This curve is a what? It's an economic model. It's an economic model. Do you know why it's an economic model? It's an economic model because the assumption here is that what drives quantity demanded of a product is only the price. Meaning that the only thing that drives Q is price. So what assumption have we made here? The assumption that we have made here is that other drivers of demand are what? Are constant. You can see that it's an assumption. We make this assumption because if you don't make this assumption, you will not be able to draw this two-dimensional plane diagram. Because this is a two-dimensional plane diagram, it can only contain two variables, which is P and Q. So, for instance, assuming you said quantity demand of a product is influenced by population, income. How do we put all these things in this graph? You can see that you can't put all this information in this graph, on this graph. You can't put all this information on this graph. That makes it difficult. So, for you to be able to have a model, you have to simplify this complexity. This is a complexity. It's very complex because you can't incorporate all these drivers, all those factors that drives demand in this what? On this particular diagram. The only thing you can put there is just one. Is to say that the only thing that drives quantity demanded is the price. And if you look at it, this we are just trying to simplify what? Complexity. Because in a real life situation, what determines quantity demanded of a product is what? What determines quantity demanded of a product are so many. We have price, income, population, taste and preferences, and so on and so forth. But because we want to simplify this complexity, we now have a model. This demand curve that we have drawn is a model. So that is why I said it's a simplified representation of reality that we use to analyze complex economic processes. So, and for us to be able to have economic model, you have to do what? You have to come up with some assumptions. One of the assumptions that we have been able to make here is that the only thing that drives our Q is P, while other factors are constant. This is an assumption. So you can see that this is a simplified version of what? Of real life situation. This is a simplified version. This diagram is a simplified diagram. Because in real life setting, what determines the demand of a product are so many. But for simplistic purposes, we assume that the only thing that drives it is what? Is price. So that is what we call model. For us to be able to have a model, we need to simplify the complexity of the real world situation. So that is why we have economic model. So now, why are assumptions necessary in economic modeling? Why are assumptions necessary? Why are assumptions necessary in economic modeling? You see, want to provide answer to a very valid question. Why? Why? Look at the reason why. Why are assumptions necessary In what? In economic modeling. Economic reality is highly complex. You have said that several times. The economic reality is highly complex, involving numerous variable interdependencies and so on and so forth. Many things affect many things. Just like I said about quantity demanded, many things affect quantity demanded. But for simplistic purpose, we said the only thing that drives it, that affects it, is price. What are we trying to do? We are just trying to simplify complexity. So now, why are assumptions necessary in the economic model? One, simplify reality. That's number one. It simplifies reality. By making assumptions, economists can what? Can strip away unnecessary complexities and focus on the core relationship that drive economic behavior. That's number one. Two, make model testable. Make models testable. It makes model testable. Assumption allow economists to develop model that can be empirically tested. That can be what? That can be empirically tested using data. That is another thing that's another reason why assumptions are necessary in what? In economic modeling. Another one is it facilitates predictions. Three, it validates predictions. It validates predictions. Three, it facilitates, sorry, not validate, it facilitates predictions. It facilitates predictions. That is, a well-structured model with clear assumptions can be used to predict economic outcomes under different conditions. What do I mean by this? You can say that, okay, if government increase taxes by 5%, how will people react? How will consumption of people react to it? What if government decide to change tax by 20%? How will people consumption behavior react to it? What if the government decide to reduce it to 2%? How will people consumption behavior react to it? You know, these are different scenarios. And if you can look at, you are making clear assumptions to predict economic outcome under different conditions. That is why we said it facilitates predictions. It helps us to predict, facilitate it. So a well-structured model with clear assumptions can be used to predict economic outcomes under different conditions. 3, 4, it allows for logical consistency. Allows for logical consistency. What do I mean by this? By setting clear premises, assumption ensures that economic model maintain internal consistency. Now what it means? By setting clear premises, assumption ensure that economic model maintain internal consistency. That is it. For instance, look at what we have said before, that quantity demanded of a product is a function of price. When there's an increase in the price, quantity demanded will fall. If there's a fall in the price, quantity demanded will rise. This is consistent because of the fact that we made some assumptions. What assumption did we make here? We made assumption that all other factors affecting quantity demanded is what? Are constant. So you can see that the internal consistency is maintained because of the assumption that we have made. So by setting clear premises, assumption ensures economic model maintain internal consistency. That's what it means. Now, if this is clear, let's talk about types of assumption in the economic model. Let us talk about types of assumptions. Types of assumptions in economic model, in economic models, types of assumption in economic models. Economic model rely on different types of assumption to structure analysis and draw conclusions. So number one of the type of assumptions is one. Let me write them out, all of them together. Types of assumption in economic model. Number one is behavioral assumptions. That is assumptions about human behavior. That's meaning of behavioral. I'm going to discuss it. Let me write them out for two. We have structural assumption. Structural assumptions. This is assumption about how the economic functions. Structural assumption. Assumption about what? About how the economic functions. Three, we have equilibrium assumption. We have equilibrium assumptions. That is assumptions about stability and balance. Assumption about stability and balance. The last one is what we call mathematical assumption. Mathematical assumption. This is assumption for analytical tractability. Assumption for analytical tractability. Now, let's take each of these assumptions and let's explain them. The first one is behavioral assumption. What do you mean by behavioral assumption? This assumption defines how economic agents behave in decision making. We have said something about economic agents in our first class when we talk about consumers, firms, and government. So the assumption that underline how these agents behave in making their decision. The example includes, let me give you an example of behavioral assumption. Assumption under behavioral assumption includes rationality. That's one, rationality. What do you mean by rationality? Economic agents make rational decisions to maximize their utility or profit. Economic agents make rational decisions to maximize their behavior, to maximize their utility or profit. But this is not often the case. It's not usually the case. At times, people are irrational. People can be irrational. But for simplistic purpose, we assume that people are rational beings, meaning that people behave rationally. And at times, if you take a look at it, people don't behave rationally. People actually can be irrational. Let me give you an instance. If you look at our laws of demand, our laws of demand says that the higher the price, the lower the quantity demanded. But in some other situation, you will see a situation that whenever there's an increase in the price, that is when the quantity demand of the product will increase. Is that not irrational behavior? That is exactly what we're saying. Some people, the fact that a particular restaurant or store offers cheap products, they will patronize it. They will prefer to go to more expensive store where they so you can, that is part of the irrational thing that we're talking about. But because of the fact that we want to simplify our discussion on how people behave, or for us to be able to model people economic attitude, we then make this assumption of rationality that economic agents make rational decisions to maximize their utility. And it's not often the case. That is the truth. And what can bring about economic not behave rationally, to be rational, at times what we call bounded rationality. Bounded rationality. There's what we call bounded rationality. Bounded rationality. Bounded rationality. This concept is introduced by Albert Simon. This bounded rationality. It's written by Albert Simon in 1955. And this concept suggests that individuals make decisions within the limit of their cognitive abilities, available information, and time constraint. That is what bounded rationality means. It means what? Human being. You see, human being. It suggests that human make decisions within the limit of their cognitive abilities. Cognitive abilities. 2, available information. And 3, time constraint. These 3 depend, work together to determine how people, behave. Limited information. Individuals do not have access to all relevant information when making decisions. That's limited information. As an individual, you don't have access to all relevant information when making your decision. The second one is cognitive constraint. Human brain has limited capacity to process large amount of information. At times, when you have large amount of information, your brain has a limited capacity to process them because you are not a computer or AI, artificial intelligence. Another thing is what we call time constraint. At times, the decision often needs to be made very quickly, restricting in-depth analysis. At times, you don't even think deeply before you take a decision. You can act on a spur of the moment. So these are things that determine the way we make decisions at times. That's why they call it bounded rationality. So the concept of bounded rationality came up or was introduced by Albert Simon in 1955. Another thing that also, another key aspect of bounded rationality is satisfaction. Let me write it out. Satisfaction. What does this one mean? It means satisfy plus suffice. Satisfying. What does this concept try to say? Say instead of finding perfect solution at time, people choose an option that meet an acceptable threshold. That is want to take a decision. You are looking for something, maybe you are looking for a particular brand of iPhone, and you get to market A, you can't see that brand, and you see something that is close to that brand. Anyway, this also meet my specification. You buy it. You take a decision of making purchase. So you can see that instead of finding the perfect solution, people choose an option that meets an acceptable threshold. That's what we call satisfaction. So all these things determines our behavior, our decision, the decision that we make. So that is why the assumption that individuals are rational can be what? Is questionable. It's not always, it's not always so. People don't make this decision at times, make decision based on some issues, some factors. Some factors also determines that. So that is what we call satisfaction. So now, but in behavioral assumption, we make all these assumptions under behavioral assumption. Rationality. Another one is self-interest. People often act in their self-interest, seeking to optimize benefits. That is another example of assumption under behavioral assumption. The first one I said is rationality. 2 is self-interest. That is, individual and firm act in their self-interest, seeking to optimize benefit. The third one is perfect information. Agents have access to all relevant information needed to make optimal decisions. Perfect information. You assume that if an individual has perfect information, and it's not often the case. At times, you don't have perfect information to make a decision. But for simplistic purposes, we just say, oh, for instance, look at perfect market. Under perfect market, we say, buy many buyers and sellers, perfect information. And if you take a look at it, it's not always so. Consumers usually don't face perfect information. At times, you may not have imperfect information, but because of the point that we are trying to drive home, we will now assume a perfect information. So all these are assumptions that we make under behavioral assumption: rationality, self-interest, and perfect information. So now, the second type of assumption is structural assumption. That is when you are making an assumption about how the economic function. So this structural assumption describe the fundamental structure of the economy. It describes the fundamental structure of the economy. So example of this includes one, market structure. The example includes market structure. Two, production technology. And three, government intervention. So this assumption we make under structural assumption. The first one is market structure. That is, market may be assumed to be perfectly competitive, or monopolistic, or oligopolistic. Production technology. Firm uses a given production function to convert input into output. This is another assumption, that firm use a given production function to convert input into output. Another one is that some model assume no government intervention, laissez-faire. That government does not intervene. Laissez-faire. So while others incorporate taxation, subsidy, or regulation. So these are all assumptions that come under what? That come under structural assumption. Market structure, production technology, and government intervention. Now, let's talk about the third assumption, equilibrium assumption. That is assumption about stability and balance. Many economic models assume that markets will reach an equilibrium state where supply equals demand. That is, many economic model assumes equilibrium, meaning that they assume that demand equals supply. But the example of market equilibrium assumption is what we call market clearing. That's number one. Market clearing. What's the meaning of market clearing? That is, price adjusts to ensure that quantity supply equals quantity demanded. That's market clearing. That is, prices adjust to ensure that quantity demanded. Let me give you an instance. Assuming we have something like this. Demand, supply. This is an equilibrium. Assuming there's a disequilibrium, there's a disturbance in this market that brings prices above this equilibrium price here. When price starts adjusting due to demand, supply being greater than demand, or demand being greater than supply, what you are going to see is that if government does not intervene, this thing is saying, because demand is more than supply, what is going to happen? People will start increasing the price themselves. As a result, what happens? Price will continue to rise until prices equate demand to be equal to supply. So this is what we call self-adjusting mechanism. So this is what we call market clearing. That if government does not intervene here, market will clear itself such that prices will equate demand to be equal to supply. That is what it means. That's what we call market clearing. Another one is what we call steady state growth. That is another example of equilibrium assumption. steady state growth. Steady state growth. Steady state. Steady. Number 2 is steady state growth. How does this steady state growth occurs? In the long run growth model, in the growth model, economy tends towards a stable growth pattern. Economy tends to what? Towards a stable growth pattern in the long run. So this is what we call steady state growth. All these are, example of equilibrium assumption. Let's now talk about the last one, which is mathematical assumption. Mathematical assumption. Mathematical assumption. Mathematical assumption. These are assumptions for analytical tractability. These are assumptions for what? For analytical tractability. Tractability. So to make model mathematically solvable, economic often assume to make model, mathematically solvable. If we specify a model to make it solvable, we make this assumption. One, we make assumption of linear relationships. That some model assume linear demand and supply curve. For simplicity, we make assumption of, in order to solve, to make a model mathematically solvable, we make this assumption of linear relationship. 2, differentiability. That is, utility and production function assumed to be smooth. If they are assumed to be smooth, that means continuous and differentiable. That is when you can differentiate them. So this is an assumption. So because this assumption of differentiability can only occur when we have our utility to be continuous and smooth, to be smooth and continuous. If you have smooth and continuous utility, yes, you can differentiate the model. So these are just assumptions that makes our model to be what? Mathematically solvable. Another one is what we call ceteris paribus, all else equal. Ceteris paribus. What the meaning of ceteris? This assumption isolates the effect of a single variable by holding other variable constant. Just like I said the other time, that the price is a function of what? Quantity demand is a function of price. Holding other variable constant. That is what we call ceteris paribus. That is the third one. Ceteris paribus. That is all else equal. This assumption isolates the effect of a single variable by holding other factor constant. Now, we have talked about assumptions. And these assumptions that we talked about, we are able to talk about this assumption about a model because of assumption. So you can see that assumption helps to simplify economic or real world complexity. It helps to simplify it. So there's a trade-off between realism and simplicity. There's a trade-off. That means there's a trade-off between realism and simplicity. Simplicity is a model. Realism is a real life situation. So there's a trade-off between them. So the advantage of the trade-off between them is that it allows economy to focus on key relationship. That's number one. It allows economy to focus on what? Key relationship. And neglect what? Ignore unnecessary details. 2, make model mathematically manageable. It makes model mathematically manageable. It can manage it because you have simplified it. The third one is it provides clear and testable hypothesis. It provides clear and testable hypothesis and testable Testable hypothesis. Testable hypothesis. So what are the disadvantages of trade-off between realism and simplicity? What are the disadvantages? Disadvantage is that it oversimplify reality. It may oversimplify reality and exclude important factor or details. That is another advantage of it. If you're trying to the trade-off between reality and being try to be simplistic is that the disadvantage is that it may oversimplify reality. As a result, it ends up excluding important factor. Another one is that some assumption may not hold in real life. Example is perfect rationality. Some assumption may not hold in real life. Some assumptions may not hold in real life. May not hold in real life. In real life. That is another disadvantage of that. And the third one, the first one is it's over. The first one, this is the second one. The first one is that oversimplification. Oversimplification of what? Of reality. By excluding what? By excluding important factor. By excluding important factor. The last one is that result may not always be applicable to real world situation. The result that you obtain using model may not, may not be what? May not happen in real life situation. For instance, this laws that says they are the price the country demanded. Of course, it hold in some cases. In some other cases, it doesn't hold. That's why I said the other time that some people may want to patronize a particular store because of the price increase, or because of the fact that the product that are being sold in that store are very, very expensive. So you can see that that is the result may not always be applicable to real world situation. Now, I want to talk about the role of assumption in different economics theory. We'll talk about the role of assumptions in different economic theories. In different economic theories. The role of assumption. We want to talk about, we have different schools of thought in economics. The dominant ones are classical economists and Keynesian economists. These are the dominant economists, schools of thought in economics. Keynesian and classical schools of classical economics. So now we now want to discuss the role of assumption under these different economic schools of thought. Number one, let's talk about the classical economists. Number one is classical economists. Classical economists. Classical economists. How do they use assumption? These classical schools of thought, how do they use assumption? They assume, this classical school of thought assume flexible wages and prices. They also assume rational decision making. And self-correcting markets. These three are very peculiar with classical school. The first one is flexible wages and prices, rational decision making, and self-correcting markets. If you look at what I said about this thing the other time, the demand, I said this is equilibrium price, this equilibrium quantity, but if there's a price above this equilibrium price, what happens? Eventually the price will come to this point because of is self-adjusting mechanism. So that is what this is an assumption. That is what this thing means. So these three assumptions are very peculiar associated with this school, classical school. The first one is flexible wages and prices, rational decision making, and self-adjusting mechanism. What about Keynesian economists? The Keynesian schools of thought. What are those assumptions that are very peculiar to them? The Keynesian school. The Keynesian school, number two, the Keynesian school, the Keynesian economists. What are those assumptions that is very peculiar to this school? One, prices or price and wage rigidity or stickiness or rigidity. Stickiness or rigidity. If you look at the classical, it talks about flexibility in price and wage. So, two is emphasizing the role of government intervention. They emphasize 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 the role of government intervention. So the Keynesian school are associated with two major assumptions. That school, if you hear, whenever you hear something about Keynesian school, Keynesian economics, that means you'll be talking about price and wage stickiness or rigidity. And what? The role of government intervention. But if you're talking about classical economics, what is common about classical economy is that, flexible wages and prices. That's number one. Rational decision making, self-adjusting mechanism, and government has no role to play in the economy. These are very common. These are so common about classical school. The third one is what we call behavioral economics. Behavioral economics. These are other schools of thought. Behavioral economics. Behavioral economics. Behavioral economics. Number three is behavioral economics. What are those assumptions that are very common with these schools of thought? One, challenges the assumption of perfect rationality. That is number one. They challenge the assumption of rationality. They challenge it, that human actions or decisions are not rational, as espoused by classical schools of thought, that these decision makers are not rational, as classical schools believe they are rational. So that is number one. They challenge the assumption of perfect rationality. As a result, they incorporated psychological insight. They incorporated psychological insight into decision making. They incorporate psychological insights into what? Into decision making. That is what is common about behavioral economics. Another one, which is the last one I want to discuss here, is games theory. Games theory. Number four, game theory. One of the assumptions that game theory, assume, one of the assumptions of game theory is that they assume strategic behavior. That's number one. They assume strategic behavior. In fact, this is the most important of game theory. They assume strategic behavior where individuals anticipate actions others' actions and respond accordingly. So that is about game theory. One of the importance of game theory is that they assume strategic behavior where agents anticipate others' actions and respond accordingly. Let me give you an example of that. If you take a look at what is happening in oligopoly market, if there are fewer sellers in that market and many buyers, if a particular firm wants to increase the price of a product, the person will try to wait and see what the other firm in that particular industry, the way they will respond, or he will try to look at the action of others before he decides to increase or reduce his own price. So you can see that there's a strategic what interaction among these fewer sellers. They look at each other before they take decision. So what helps to capture that is game theory. So strategic behavior is very important, or is associated with game theory. That is what we are trying to say there. So on that note, I want to rest my case and ask if there are questions from the floor. Any question for me? Any question for me? Any question for me?
No, sir.
Okay. So, Omo, Olabode.
Yes, I have a question.
I have a question.
You guys are free to ask. You are free to ask.
All these scholars.
Which of these assumptions are used? Like in our present world, which of these assumptions are used?
Anyway, that's a very brilliant question you have asked. But those assumptions that I raised, they were raised under different schools of thought. We have different schools of thought in economics. But the most important schools of thought as we speak now is behavioral economics. Behavioral economics. Because unlike the classical and Keynesian economics that assumes that, price, if you look at what I said about Keynesian economy says wages and prices are stickiness. They assume rigidity about prices and wages. And again, if you take a look at the classical schools of economics, they also assume, which is very critical to that schools of thought, one of the assumptions of the classical school that is very critical is rationality. They assume economic agents are rational. But what we're saying here is that economy agents are not always rational in their decision making. So the schools of thought that capture that is behavioral economics. That is why I said the behavioral economics incorporated into the study of economics what we refer to as what? If you look at the note that I gave just now, I said they incorporated psychological insights. Yes. Ayodele Kende, please feel free to ask your question. Feel free to ask your question.
Thank you, sir.
Ask your question now.
I'm listening.
Good morning, sir.
Morning.
Yes, sir. Sir, please, I want to ask under the empirical method. Under the weakness. Sir, please, what's the third one?
The third one?
Yes, sir.
The third one, okay, let me check my slide here. I think the third one is okay, empirical, Abi. Issues that is multicollinearity, endogeneity, and omitted variable bias. Omitted variable bias. Omitted variable bias. Endogeneity, multicoloniality, endogeneity, and omitted variable bias.
So please can I get the slide?
Thank you, sir.
Okay.
Sir, please can I get the slide?
Yeah, please can we get the slide?
So on this note, if you do have any other question, I want to thank you for your cooperation, and I will make my note available as usual, because the whole essence of this exercise is to take you through what is the terrain, what is the frontier of knowledge, because if you look at what is happening in the academic world now, it's rapidly changing, it's dynamic. You don't have to stick to a particular mode of teaching most of the time. So on that note, I'm going to make my note available to your course thread. Thanks so much.
That's what the course outline.
Sir.
Thank you,
sir. The course outline also, I promise, I'll make it available. It will be made available today for each and every one of you for further reading.
Thank you, sir.
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 Go in class and the teacher question. Ah, God.
My threatening me.
I want to ask question. I want to ask question.
You threatening me. Bola, where that Bola?
Why you on mute, Mike?
Why you talk?
Shut up, Daddy.
Hey,
I do not say, come out.
I know
that
come on inside, Jerry.
Come out. They threatening me.
Come on.
Come out.
My red button,